Section 7.3 is about sum and difference identities. These identities might be on your cheat sheets, but in case they're not, I have a nice handy way to remember these trig identities. But first of all, what are these? If we want to know, so far we've only dealt with angles that are either 30 degrees, 60 degrees, or 90 degrees, or 45, 45, 90. But what these identities do for you is it will allow us to figure out the trig ratios very quickly of any other kind of angles that we can make a combination of 60 plus 45 or 30 plus 45 or 45 plus, well, that's 90, but anything like that, it'll allow us, or if we subtract, it will allow us um, to find the trig ratios of those equations very easy. So like we could find the sine of 15 or the cosine of 15, or if you add these, we could find the sine of 145 and all that stuff. Any common angles that we know, even like 135 plus 45 or 100 simple angles that we know, 210 plus 45, stuff like that. We can find all those angles using our sum and difference formulas. It says if A and B represent the measures of two angles, then the following identities hold true for the values A and B. It says the sine of angle A plus or minus, depending on how we get to this specified angle we want to get to, B, equals the sine of A cosine of B plus or minus sine of A cosine of B. Notice now, these signs are written in a very specific order. It means if this is saying, if this is a plus sign in between here, this is a plus sign in between here. If it's a minus sign in here, then it's a minus sign inside of here. Now, if we're dealing with cosine, all right, if this is a plus sign in between, it's the opposite. It'd be a minus sign here. If it's a minus sign inside the parentheses, it's going to be a plus sign. The handy way I remember how to, or how I remember how to say these formulas is this right here. I remember it sine, cosine, cosine, sine, cosine, cosine, sine, 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 with the third, almost the third to last sign being spelled differently. And I emphasize that one when I say, knowing that it doesn't actually mean the sine, the trig function, but it means sine, change these signs. It means opposite signs. So how I remember it is sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. Okay, that's how I remember it. Sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. All right. That's how, as a trick that I use to remember it. So find the cosine of 15 from the values of the functions of 30 and 45 degrees. So like I said, this typically we don't know what the ratio of that is because it's not an easy angle to find. But now that we know these identities, we can figure that out real quick. And I'm going to scroll up so we can see our identities. All right, so it's saying cosine of 15. Well, to make 15 out of 30 and 45, we got to subtract these two. So I'm going to say we want to find the cosine of 45 degrees minus 30 degrees. Would you agree that 45 minus 30 is 15? I sure hope so. So what our equation is saying, okay, we're using the cosine. All right. So the cosine of A, which is 45 degrees, times the cosine of B, which is 30 degrees. And then you got to change the sign since this is a minus, and that means this is a plus. These are opposite, remember? This has got to be the sine of 45 times the sine of 30. And we know how to find these. Some of us, we still struggle with this a little bit, but that's all right. What we need to do is draw our special right triangle, okay? This is, we're trying to find a 45, 45, 90. We want to know the cosine of 45 degrees. 1 square root of 2. And so the cosine of 45 degrees would be, the adjacent would be 1 all over the square root of 2, or square root of 2 over 2. Just getting rid of the radical on the denominator. We've been through that. And then we need to know the cosine of 30 degrees. So we need our 30, 60, 90 triangle. This is 1 square root of 3, and this is 2. The cosine of 30 degrees would be the square root of 3 over 2. Okay, so then we're going to add the sine of 45. Sine is opposite all over hypotenuse, so the square root of 2 over 1 times the sine of 30. The sine of 30 is 1 all over 2. So to find our trig ratio, we multiply. This would be the square root of 6 all over 4 over here, so the square root of 6 over 4. And if we multiply here, it'd be the square root of 2 over 2. And then if we wanted to add get common denominators, we would multiply this by 2. So this would be 2 square root of 2 over 2. So we would have this trig ratio would be 2 square root of 2 plus square root of 6 all over 4, if that's how you want to write it. And then we could also figure it out using our calculator, figuring out what the actual value is as well. Okay. So again, this is kind of the same deal. Find the sine. All right. So we know that it's the sine of 45 minus 30 would give you 15. All right. So it goes sine, cosine, cosine, sine. So the sine of 45 degrees and then the cosine of 30 degrees, same sign in between, minus, okay, the sine, cosine, cosine sine, sorry, the cosine of 45 times the sine of 30. That's what your equation says. And again, we've been through how we find all this. The sine of 45 degrees is the square root of 2 over 2. The cosine of 30 degrees is 1/2, I think, right? I better check to make sure. No, it's not 1/2. Sorry, that's square root of 3 over 2. I didn't think that seemed right. All right, minus the square root of 2 over 2, and we know that the sine of 30 degrees is 1/2. There we go. That's where I was messing up. So then we multiply again. We get the square root of 6 over 4 minus the square root of 2 over 4. So we could rewrite it as the square root of 6 minus the square root of 2 all over 4 for our answer. Okay, so hopefully this is pretty self-explanatory. Sum and difference for tangent, and has a separate separate formula. I cannot give you an easy way to remember this for the life of me. I haven't been able to come up with one. If you come up with them, with one, let me know. I'm pretty sure it's on your cheat sheet. So notice that this sign is the same as the one inside the parentheses. This one is different. So the tangent of 105, think of two angles that we know that add up to be 105. I can think of 60 plus 45, right? So let's use that, the double angle formula, to find the tangent of 105. All right. So that means we're going to have the tangent of 60 plus, because it's the same sign as the one inside here, the tangent of 45 all over 1, and then this has got to be minus because it's opposite the sign up here. The equation says opposite here. The tangent of 60 times the tangent of 45. One nice thing about this equation is you only have to find two trig identities. Once I know the tangent of 60, tangent of 45, it goes in down here as well. That's one nice thing. So I'm going to draw a 30, 60, 90 triangle. And I'm going to draw a 45, 45, 90. One question that comes up when we do these is it doesn't matter what order you do this in. And I'm going to say no. As long as these two added together equals 105, it doesn't matter. And if there was another angle that we knew, say a different one of these where we could have added two separate ones, like, you know, instead of 45 and 60, we could use two different ones like 90 and 30 or something like that. That would come up to be the same angle. It wouldn't matter which one you use. You'll still get the same answer, just as long as inside of here adds up to be this guy. So anyway, all right. To finish off my equation, this would be the square root of 3. This would be 1. This would be 2. This would be 1, 1, square root of 2. So the tangent of 60 degrees, opposite all over adjacent, would be the square root of 3. Plus the tangent of 45 is the square root of 2 over 2. All over 1 minus the square root of 3 times the square root of 2 over 2. So in here we would get 1 minus the square root of 6 all over 2 on the bottom. And up top, if we want to get a common denominator, this would be 2 square root of 3 over 2. So we would have 2 square root of 3 plus 2 square root of 2 all over, or no, not 2 square root of 2, just square root of 2, all over 2. Or on top. And we can do some farther, we can simplify this farther if we want. If we wanted to get a common denominator here, this would be 1/2, or sorry, it'd be 2 minus the square root of 6. I'm messing up now. I hope I'm not confusing you. But what we have here, if this is our top, 2 square root of 3 plus the square root of 2 all over 2, and this is divided by the bottom, which is 2 minus the square root of 6 all over 2. Remember, when we multiplying or dividing fractions, we save it, change this to multiplication, and flip this. So if we were multiplying, it'd become 2 all over 2 minus the square root of 6. Notice that these now cancel out. That's what I was trying to get to. And so our final answer would be 2 square root of 3 plus the square root of 2 all over 2 minus the square root of 6. I was just doing some simplifying here by getting common denominators and then saving it, changing the sign, and flipping it when we multiply fractions. Okay. Hope that little part didn't confuse you there. All right. In this equation right here, it says we have two angles. If one angle is a tangent and that equals 45 or 4 over 3, and the cotangent of B equals 5 over 12, find sine of B minus A. Okay, so what this means is we have two triangles, and in one triangle, we have an angle that has a tangent ratio of 4 over 3. Tangent means opposite all over adjacent. And in another triangle, it means we have a cotangent of 5/12. Cotangent would be adjacent all over opposite. We can find our other ones by using Pythagorean theorem, but this is 5 and this is 13. They're easy Pythagorean triples. So they want to know, find the sine of this angle here minus this angle here. Well, easy enough, okay? So we know that the sine of A minus B is the sine of A times the cosine of B. Same sign in between, minus the sine of sine, cosine, my bad. The cosine of B, or sorry, A, man. Sine of B. All right, so sine, cosine, cosine, sine. All right, and so all we gotta do is now find the sine ratio of A. So this was A, right? And this guy was B. Okay. So find the sine ratio of A, and that's 4/5. The cosine ratio of B, this guy is 5/13. Minus the cosine of A, so this guy was A, which would be 3/5. Times the sine of B, sine of B would be 12/13. And then we can multiply these out. And to save time, I'm not going to do that. You guys can multiply and add, subtract fractions. Okay, and the reason for that is because this last one right here, verify that cotangent of x equals the tangent of pi over 2 minus x. Verify that that is an identity. Okay, so we have tangent of pi over 2, or tangent of 90 degrees, minus x. This is what we're going to want to use, tangent of A plus or minus tangent B over 1 minus tangent A tangent B. All right, so we're going to have the tangent of 90 degrees, that's the same thing as pi over 2, minus the tangent of x all over 1 plus the tangent of 90 degrees times the tangent of x. Sorry for the pause there. I had a student come in. If I write this equation out, I notice that I have the tangent of 90 minus the tangent of x all over 1 plus tangent of 90 tangent of x. This was my first instinct on what to do, and I noticed that I need to find the tangent of 90 degrees. Well, if you look at your chart, or if you think about the graph of tangent from negative 90 to 90, that graph is undefined, so this is an undefined value, so that's not going to help me out at all. That's not going to get me to where we want to go on this equation. So we're going to have to think of something else. Here's something that we can think of. This is the only thing that I can think of. I'm not sure if this is going to work, but we'll try it out. We know that tangent equals the sine over cosine, right? So maybe if we write this as the sine of 90 minus x all over the cosine of 90 minus x, it's going to work out. Again, I'm not sure. But that's the only other option I know for tangent. And let's try to use these summation formulas here. So the sine, this angle, remember this goes sine, cosine, cosine, sine. So it'd be the sine of 90 cosine of x. Same sign in between. So minus sine, cosine, cosine of 90 times the sine of x. all over. This would be sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. So I know that this sign has to be different. This is going to be a sine, this is going to be a sine, and this is going to be cosine. I need to fill in, this is going to be 90 and x and 90 and x. All right, so the sine of 90 degrees, what is the value of sine at 90? Well, that is 1. So I have 1 times cosine of x minus the cosine at 90 degrees is 0 times sine x. All over the cosine of 90 degrees, again, that's 0 times cosine x. And then plus sine of 90 is 1 times sine of x. It looks like this is going to work out. 1 times cosine is cosine minus 0, so we don't need to write that. All over 0, this is 0, plus sine of x. Cosine x over sine of x, that equals cotangent of x. So that did end up working out. Well, I'm glad it did. I hope this helps. We'll see you in class.